So guys, this video is a follow-up to the video that we did on interval notation. What I'm going to do in this video is we're going to talk about all of these different key features that we need to be able to identify when we're looking at the graph of pretty much any type of function that we've covered so far. Now, what I think we'll do is we'll actually have a separate video that looks at each function, so that way it's not one long video. So when we look at the different key features we need to be able to identify, we already know about domain and range. We need to be able to find, number 6, we need to be able to find intercepts, so x-intercepts, y-intercepts. Remember, an x-intercept, another term for that is called a zero, okay? We need to be able to identify then intervals where the function is increasing or decreasing, and intervals where a relation or function is positive or negative, okay? When we're trying to identify these 4 things, domain, range, increase and decreasing intervals, or positive or negative intervals, those can be represented using the inequalities or using the interval notation. As you move on up into higher math, you will begin to use the interval notation a lot more. The inequalities don't go away, but you begin to see the interval notation a little bit more. So then the other things, we need to be able to identify maximum and minimum values. So that means the vertex of a quadratic. And later on when we talk about polynomial functions, relative maximums and relative minimums. And then asymptotes. So those are going to be like with your exponential function or with your rational function, where you've got to find what are those lines that the function seems to approach but never quite touches. So to start us off, let's just look at a linear function. So linear function, I put the equation for that function right here. Y equals -1/2 x minus 1. We're going to identify just all these key features here, guys. So the domain. So if we think about the domain for a linear function, we're talking about all of the x values that we have on the that the function touches on the graph. So if we think about it, if we're going from left to right, we're coming all the way from negative infinity. We're going all the way into positive infinity, and it just keeps on going. We're hitting every single x value on that graph. So we would say all real numbers, that we could just say that, all real numbers. But when we talk about domain and range using interval notation, to say all real numbers, we say negative infinity to positive infinity like that. This represents the same thing as all real numbers does using the interval notation. So we need to begin using this more regularly, okay? Range, it's the same idea. As we go from the bottom to the top of the graph, we see that, well, that line is going to touch every single y value going all the way down into negative infinity and all the way up into positive infinity. So again, all real numbers. But then because all real numbers, we would say negative infinity to infinity using our interval notation. So slope, we should be able to look at an equation of a line or just look at the graph itself and identify what the slope happens to be. So the slope, we're in slope-intercept form, y equals mx plus b, there's our slope. Or if you're looking at the graph, find any 2 points. So let's take that point and we'll take this point down here. Rise over run, we go down 2, right 4. So down 2 is a -2, right 4 is a +4. That reduces to -1/2. Any 2 points on the graph, you should be able to use those 2 to find the slope. So our slope, we'll actually say m equals -1/2 because m is what we use to represent slope. X-intercept, where the function crosses the x-axis, you should be able to, when you look at a graph, guys, automatically start zoning in on where the intercepts happen to be. Here's our x-intercept at -2, 0. And our y-intercept is at 0, -1. Now, positive and negative. This is where we've got to take just a moment. So positive and negative, that refers to where the function is above the x-axis and where it is below the x-axis. So normally where that happens, a lot of the time, guys, is where your x-intercept is. So our x-intercept is at 2, -2. If I were to draw a line right through where x is 2, This part of the graph is positive because it's above the x-axis. This part of the graph is positive because, is negative because it is below the x-axis. So what we then need to do is, using the domain values, so our x's, we need to come up with an interval, inequalities and interval notation, that represents those particular sections of the graph. So this part over here that's positive, the x values for that part of the graph are less than -2. So with an inequality, we would say x is less than -2, or with interval notation, we would say -∞ to -2. The negative interval then would be the opposite of that. This part of the graph, those x or domain values are greater than -2. So we would say x is greater than -2, and then using an interval, we would say we would say -2 to +∞. Now, we don't include the line underneath the signs there, guys, because at that x-intercept, we don't want to actually include it, because if you think about it, the value of that function, the y value of that function, where x is -2, is 0. If it's at 0, that y value of 0, that means it's on the x-axis. That's not positive or negative, okay? So we don't want to actually include that -2 whenever we state the positive and negative intervals. So then increasing and decreasing. When we figure out increasing and decreasing intervals, when you look at a graph, always read the graph from left to right. So start at the leftmost part of the graph and see what's happening. So if we start at the leftmost part of that line and we follow along, is it going up or is it going down? It's going down. So that means then the interval of decreasing, we would say all real numbers, or using our interval notation, -∞ to +∞. The interval of increase, if we go from left to right, there is no interval of increase. So you can either just put none. Some of the time you might see what's called the empty set symbol, so just an O with a slash through it. That's probably not going to be a question that's asked often, guys, but it is something that you need to recognize, that there is no interval of increasing. And then in behavior is asking what happens to the graph what happens to the function as x approaches -∞ and as x approaches +∞. When we express in behavior, you're always going to have x approaching something twice. So we've got x approaching -∞ and x approaching +∞. And you can think of it, guys, as think of what is the left arrow doing, what is the right arrow doing, if you just have the two arrows. If you don't, then we've got to think about it a little bit differently. So then the left arrow, that is the same thing as saying x approaches -∞. Well, that arrow is going up towards +∞, so we would say that y approaches +∞. Then the right arrow, what happens as x approaches +∞? Well, it's going down, so we would say y approaches -∞. Those are the key features from a linear, quadratic, whatever type of graph you're given, you need to be able to recognize.